Today we will be looking at real numbers. The rational and irrational numbers together make up the real numbers. The set of real numbers is denoted by R. Like rational numbers, irrational numbers can be represented by decimals, but unlike the decimals for rational numbers, those for irrational numbers are neither finite nor recurring. All such infinite, non-recurrent decimals represent real numbers. Each real number can be represented as a point on a number line. In this section, we will also look at some different systems of numbers and then rules for combining numbers in these systems. For each system, we consider the question of which elements have additive and or multiplicative inverses in the system. Now, let us look at the different types of real numbers. So, we have different types of real numbers. Let us look at them in detail. The first one, we have your natural numbers that are denoted by an N. Right, so your natural numbers are your positive whole numbers. Your natural numbers are your positive whole numbers, that is from 1 up until positive infinity. 1, 2, 3, 4, 5, 6, 7, 8, 9 up until positive infinity. We're talking about your natural numbers. These are your positive whole numbers. We're talking about all your positive whole numbers. The second one, we have your whole numbers. Whole numbers are denoted by an N with a small o here. This in fact is not an O but a 0. So it is an N with a 0 at the bottom. So these are your natural numbers that include a 0. So your whole numbers are your natural numbers including 0, right? That is for 0, 1, 2, 3, 4, 5, 6, 7, 8 up until positive infinity. So your whole numbers include a 0. They are natural numbers, but they include a 0. So the difference between natural numbers and your whole numbers is that natural numbers are positive whole numbers. They do not include a 0. As you can see here, I started with it from a 1, not from a 0. So, but your whole numbers are all your positive whole numbers, including a 0. The third one now are your integers. So integers denoted by a Z. So integers are numbers you find on your number line. So if I say these are numbers you find on a number line, it means that your integers can either be positive or negative. Your integers can either be positive or negative. So we have an example here from 0 plus or minus 1 plus or minus 2 plus or minus 3 to plus or minus infinity, right? So at 0, positive or negative 1, positive or negative 2 up until positive or negative infinity. You can notice that any natural number is an integer. Any natural number is an integer, but not any integer number is a natural number. The fourth one are your rational numbers. Your rational numbers are denoted by a Q. They are represented by a q. A rational number is a real number. Is a real number which can be written in the form of a over b. So rational numbers can be written in a form of a over b, meaning in a form of a fraction, where a and b are elements of integers. Where a and b are elements of integers, but b cannot equal to a 0. Remember that b is a fraction, and immediately when we have a fraction that has a denominator of a 0, it will give us an undefined number, which is a problem. It is a very big problem in mathematics. We do not want an undefined number. We can therefore say any integer number is a rational number. Any integer number is a rational number. However, any rational number is not necessarily an integer. Right. So for an example, we have 2 over 1. This is written in the form of a fraction, right? It is written in the form of a over b. 2 over 1 is a rational number. Another example, 0, 2. 0, 2 can be written as 2 over 10, which is a fraction, which can be simplified to 1 over 5. We have again 0, 2 recurring, can be written as 2 over 9. It is also a fraction. We have 22 over 7. So here, note that 22 over 7 is not equal to pi. 22 over 7 is not equal to pi. Therefore, it does not make pi to be rational. So we shouldn't assume that pi is rational, because 22 over 7 is approximate. It is an approximate rational number to pi. We have the fifth and last one, which is your irrational numbers. Irrational numbers are denoted by a q with a dash there on top. So these are numbers that cannot be expressed as a ratio. They cannot be expressed as a ratio of fractions, right? Right. They cannot be written as a fraction, basically. So real numbers that are not rational are called irrational. Example include pi, root 2, and so on. One distinction between rational numbers and irrational numbers is that rational numbers have repeating or terminating decimal expansions, whereas irrational numbers do not. Basically, irrational numbers have no pattern. They are indefinite. I gave an example of root 2. Root 2 doesn't have a specific pattern. It doesn't follow a pattern. It will be 1,414,2,1,3,6 going forward. Same as your pi. Pi will be 3,141,592654 going forward. So it doesn't have a pattern. Therefore, we say it is an irrational number. We say it is an irrational number, right? If I had maybe an expression like 1 plus root 5 over 2, 1 plus root 5 over 2, what will I get? I will get a 1, 0.6180339989 going forward. So this doesn't have any pattern. But if we were talking about your rational numbers follow a specific pattern, right? They can be represented as a over b and also follow a specific pattern, right? But not always. But then if your decimals cannot be represented as a fraction, but those decimals are recurring, therefore we say they fall under your rational numbers, right? If we take, for an example, 2 over 9, we say 2 over 9 is a rational number. If I take 2 over 9 will be 0, 2 going forward. So this, or 0, 2 recurring. So this, we say these are your rational numbers, right? So they can be recurring. They can be written as a fraction and also they are recurring. Let us now have a look at non-real numbers. A root of a negative number is a non-real number. So these are roots of negative numbers. For example, a root of negative 2 will be a non-real number. A fourth root of negative 100 is a non-real number. A third root of a negative 1000 is a non-real number. So, hence we say a root of a negative number is a non-real number. The calculator will show a math error when you punch all of these digits. When you punch a root of negative 2, it will be a math error. When you punch the fourth root of negative 100, it will be a math error. If you punch a negative root of a fifth root of negative 100 of a negative 1000, it will be a math error. Sometimes when you solve your quadratic equations, we sometimes get undefined numbers or your math error, right? Let us try to solve one problem. We have x squared minus 2x plus 5 equal to 0. They say solve for x. So as you can see here, we cannot find any factors of 5 that when we multiply, they will give us a 5, and when we add or subtract, they will give us a negative 2. Therefore, we will have to use our quadratic formula. When we use our quadratic formula, what do? We will say x is equals to negative b plus or minus square root of b squared minus 4ac, everything over 2a. So this is the formula for solving a quadratic equation, right? So we have my a here, I have my b here, we have my c. So a is 1, right? A we have 1, right? And then b we have negative 2. C we have a 5. So where there's b we put negative 2, where there's c we put 5, where there's a we put a 1, right? So where there's a we put a 1, where there's b we put a negative 2, where there's c we put a 5. So we will have x is equals to negative b, it will be positive 2 because my b here is negative, and negative times a negative give me positive. Therefore, I have positive 2 plus or minus the square root of negative 2 squared minus 4. What's a? A is 1. C is 5. Right. Everything over 2a was my a. It's 1. You punch everything into a calculator. What do you get? You'll get that x is equals to 2 plus or minus square root of negative 2 to the power of 2 will be a 4 minus 4 times 1 is 4 times 5 is 20, meaning it's negative 4 minus 20 give us negative 16 over 2 times 1 is 2. So can we simplify any further? We cannot do anything here. So my square root here is a negative. Therefore, this is what? It's a non-real number. So we can see that there is no solution, right? The problem will be x is non-real, is a non-real number. The problem will give us x is a non-real number. That is where your complex numbers arise naturally as a solution, but you learn those when you are to take math university. So we can see that there are no real roots for the equation. So the equation of the function x minus 2x plus 5 will have no roots, will have no x-intercept, right? It will be something like that. It will have no x-intercept.